Hello everyone, this is Taylor, and in today's video we're going to be walking through question 2 of the MAS 1 Spring 2019 exam. Let's get started. You are given the following information about the waiting time until a certain number of events occur. 1. The underlying events follow a homogeneous Poisson process. 2. T underscore n is the time until the nth event occurs. And 3, the expected value of the time until the second event occurs is 2 units of time. Calculate the variance of the time until the 10th event occurs. So there's a lot going on in this question. In terms of the background knowledge you need to have in order to approach this problem, first you need to know that the underlying relationship between a Poisson and an exponentially distributed variable. So Poisson has the hyperparameter lambda, which is the it is the expected number of events to occur in a specified unit of time, whereas an exponential distribution is the expected number of time until the first event occurs. And so when you're interested in one event occurring, there's that relationship of theta equals 1 over lambda. So if you expect one event to occur per one unit of time, then you would also expect that the time until the first event occurs is 1 unit of time. I realize that's a mouthful, but hopefully that made sense, just that there is that underlying relationship. The second point you need to know is that the sum of multiple exponentials, assuming they all have the same theta, is distributed as a gamma with that same theta value, but where alpha is just n. So that is, we're going to have these multiple moving parts in terms of, eventually we want to address when 10 events occur. So in our example, we're going to eventually deal with alpha equals 10, but we're going to be interested in breaking it down into that smaller subcategory of 1. So an exponential, the time until one of those events occur, and then there's going to be 10 of them. And then finally, this variance calculation. So this, if you're taking MAS 1, I'm assuming you already took P probably, so this should be pretty straightforward, but just to maybe be a refresher that the variance of x is equal to the expected value of x squared minus the expected value of x squared. I would say maybe the one additional thing is just the memoryless properties of the exponential distribution. That kind of comes into play into this as well. So going into the calculations, first we were told that the expected value of the time until the second event occurs is 2. So that's that expected value of t subscript 2 equals 2. Going back to our point where we said, okay, well, we know that it follows a Poisson process, but when we break it down to only caring about the time until one event occurs, we can actually take this Poisson and make it an exponential. So really we're dealing with exponentials here. And then since it's an exponential and we want the expected time until the second event occurs, that's really the same as saying what's the summation of two exponentials. And the reason why I mentioned that memoryless property is because we wait until that first event occurs, and that's the first exponential. And then from the point where that first event occurred until the second event occurred, because exponential is memoryless, essentially you can think of it as having that fresh start, given you made it up to that point. Really we're just taking the sum of two separate exponentials with the same theta, and that's where we bring in that relationship of the exponential distribution with the gamma distribution. So at this point, this weird looking formula that you're seeing, that's just again going to the formula sheet that's going to be provided for the exam, and you can just jump right on down to this would be that expected value of x to the power of k, where k is just 1, is all I'm doing here. So with that, we say theta times gamma of alpha plus 1 over gamma of alpha. In this case, alpha is 2, so we just plug that in. The gamma function is just gamma of n is equal to n minus 1 factorial. So that's how, this 2 is really 2 times 1 divided by 1. And then we can solve for theta. And all of that work just leads to us saying that, okay, we know theta is 1. So we expect one event to occur per 1 unit of time. So now that we know this theta parameter, we can jump to the next portion of this question, which corresponds to when alpha is 10. So we want to know what is the variance for the time until the 10th event occurs. So with that, this gets to, we want to know this variance, and so we're going to call on this formula, again, expected value of x squared minus the expected value of x squared, and then again, using that expected value of x to the k power, we can make that calculation twice. So that's what we're doing here. So really we're just repeating what we did above, but now we're going to plug in 10 instead of 2. And that's how we get this formula. So really, I broke this down to way more steps than you would if you were solving this during the exam, but just really wanted to make clear how you plug and chug if in case you made errors like I probably did the first time trying to solve this. So here we're going to say 10 plus 2, so that's your 12. Then we say gamma of 12 is the same as factorial 11. Do that for all of these. We have all these factorials. And then the second to last line is something that you would never write out when solving, but it might be useful if you didn't know this shortcut. But when you have a division of 2 factorials, you're really just taking the numbers that are greater than the denominator, and that's all you're left with. So 11 factorial is 11 times 10 times 9 times yada yada yada, divided by 9 factorial, and you can see that 9's cancel, 8's cancel, 7's cancel, so on and so forth. And so all you're left with is that 11 times 10. Then same thing for the second component, but it's only greater than 9 by 1. So instead of 2 numbers, you only have 1, which is that 10. And that's all you're left with. Probably already aware of that, but just thought I'd walk through that kind of quickly. So, plugging and chugging, we've gotten this far, you already did the hard part. And then at the end of this, you get the value of 10. So we expect the variance of the time until the 10th event occurs to itself be 10. And really just doing a quick sanity check, does that kind of make sense if you'd expect to see one event to occur per 1 unit of time? And to me it does, right? So that's to say the standard deviation's like a little over 3, and that seems reasonable in the grand scheme of things. So when we get our 10, we go up, and that falls in the interval of C, so our final answer for question 2 is C. So that concludes this video. Thank you for watching. Please consider subscribing if you find these videos helpful. Thanks. Have a good one.